Hello, I'm Philip Hubbard from the Genelia Research Campus of the Howard Hughes Medical Institute. Welcome to the second tutorial on using the neuPrint and neuVid systems to make high-quality videos of Drosophila neurons. In the first tutorial, we covered getting set up, getting data from neuPrint into neuVid, and animating visibility. In this second tutorial, we'll go further, looking at easy ways to get nice-looking camera motion. Let's get started.
I'll assume that you've done the setup from the first tutorial. You've downloaded and installed Blender, and you've either downloaded the zip file of the neuPrint scripts, or we can just clone the repo here. Now we're ready to get some content from neuPrint. I'm going to use this input pathway to the Drosophila compass system. Starts with the tubu01 neuron, goes to an ER4M, and then ends up at an EPG. Let's take a look at that in NeuroGlancer. We don't need to see the synapses, so I'll click to turn those off. Then we go over to this important copy URL to clipboard button. Click to do that, and then we can go back to the neuVid scripts to import it. So remember, we run those in Blender. We run Blender in the background with the Python script. Import ng, 2 dashes, and then we're going to output to, we'll call it example3.json to continue on after the 2 from the first tutorial. So now we can run the next script using that JSON file as input. This one will import the meshes. Then we run the script to add the default animation. And now we can preview that in Blender. So we open the example3 anim file. And we can play that. So that looks quite reasonable, but it could be more interesting if we started with more of a close-up view at the beginning and then gradually transition to a wider view at the end. So let's see how to do that. Go to Visual Studio Code, open our JSON file, and then we're going to make small changes to the frame camera and orbit camera commands that we saw from the first tutorial. In particular, we're going to add a new argument called scale. Now, scale is a factor that multiplies the camera distance. So if we set the scale to less than 1 on the frame, that will bring the camera closer to the neurons it's framing on, making them look bigger. I usually start with, say, a value of 1/2 here. Now, for the orbit camera, normally it'll stay at that distance as it rotates around the neuron it's looking at, but we can add a scale here, bigger than 1, and then we'll gradually transition to being farther away from the neurons at the end of the orbiting. That gives sort of a spiral effect. So let's try that. But actually, before we do that, you might misremember what scale is for the argument here. You might guess that it's zoom. That'd be a very reasonable guess. So let's see what happens if you do that. Go over here, run add animation again, and we get an error for the frame camera command. It's saying that it doesn't recognize this argument zoom, but it tells you that the arguments that it does recognize, and one of them is scale. So hopefully that would be enough to jog your memory and help you go back in here and fix it to scale. Now we can go do the add animation. It works. Go back to previewing in Blender, load the file again, and revert is a convenient way to do that. That'll reload the file. And so now we have a closer view here, and as the orbit proceeds, we pull out to a wider view. I think we could make it look a little better if it wasn't quite as close here. So let's go back to the script, change this to, let's try 0.6 and 1.6, and run that again. It's quick to iterate like this because add animation runs quickly. Go back to the Blender preview, reload the file, and now it's zoomed in close but not quite so close. There's still a little bit of the neuron clipped off of the side, but I think that's okay. That makes it look a little bit more exciting and dramatic at the beginning, and then it gradually pulls out as we're going along to this final view. So altogether, I think that looks pretty good. And we can go and render the frames now. So we just use the render script. Now we can assemble all those frame files into a video file with the assemble frame script. Now let's take a look at that. That looks pretty good. That's a nice way to get some camera motion when we want to see all the neurons at once. Now, let's look at a different technique to use when we have animated visibility, when the neurons are appearing one after another. We'll start by putting in that animated visibility using the fade command we learned about in tutorial 1. We can take out the scale that we added. Then, for a moment, we'll go back to neuPrint, and we'll notice that the ID for the tubu01 matches the ID for N1 in our script, and the ER4M matches N2, EPG matches N3. So that's the order we want to have them fade on. So let's go in, start adding the commands. We'll do fade, meshes, neurons N2 because N1's already visible, starting alpha 0, ending alpha 1, and let's have it take, say, 1 second. Then we need to advance time by that same 1 second. And then we do the same thing for N3. Go back, add the animation, and preview it in Blender. And we see N1, N2, N3, just the way we want. All right, now we're ready to add the new camera motion. And we're going to use the same frame camera command that we've used before, but we're going to make a few changes to its arguments to get the behavior of focusing on the neurons that are becoming visible. So first, we want to focus on just N1. That's the first one that's visible. And let's copy this, go down here, Second, we're going to focus on N1 and N2 using the plus sign there. And then also we don't want this focusing to this framing to happen immediately. We want it to be animated, moving over to that new framing. So we give it a duration of 1, and then we can copy this. And down here, we want to frame on N1, N2, and N3. We could do it like that, but it's also a little shorter to just say all the neurons. All right, so let's generate the animation for that. Go back up here and preview it. And so we see starting out with N1, then N2, N3 with some nice camera motion to go to what's visible. Now, you may have noticed that we didn't have any advanced time between the fade and the frame camera. If we wanted to, we could put one in. That'll have a different effect. That means that the fade will finish before the frame starts. We can try that in all three. Take a look at how that looks. So fade, frame, fade, frame, fade, frame. Well, that's interesting, but on the whole, I don't think I like it as much. So I'm going to take it out. Go back, undo, undo. All right, now let's put in one final bit of camera motion. Notice that we don't have any orbiting anymore. And orbiting is useful because it lets us see the neurons from different sides. And that helps us get a better understanding of their three-dimensional shape. We call that motion parallax. So we can add some orbiting in, but we're not going to do full orbiting all the way around like we've done before. We're going to do partial orbiting with a new argument. So let's do that. Let's do orbit camera. And then the new argument is ending relative angle. So let's do a little rock forward, rock back, and then rock forward again. So we'll do ending relative angle of 15 degrees with a duration of, let's say, 1.5 seconds. Advance time by that same 1.5 seconds. Then, so that's the rock forward. Then rock back, we would do a negative angle, the other direction, and we'll go all the way around the same amount to the other side and have that take twice as long, 3 seconds, and then rock forward again. So notice that what we have here doesn't have any reference to the particular neuron that the camera is looking at. The camera just orbits around what it's looking at, and that means we can copy this block and we can reuse it in the other two cases. Just have to make sure we have commas in the right places. Now let's go add the animation for that. And preview it. So rock one way, rock back, return to neutral, frame, rock one way, rock back, return to neutral, fade and frame, rock one way, rock back, return to neutral. So that actually looks pretty good. let's go and render the frames for it. Actually, before we do that, let's copy the frames from that earlier example we did. And then let's render. Now we can assemble the frames. And take a look at the result.
I hope you can use these techniques to add interesting camera motion to the videos you're making. Remember, take a look at the documentation on the neuVid GitHub site and add an issue if you have any problems. Have fun with your videos.